Welcome to BKW Physics. I'm Mr. McConley, and today we're going to do a classic demonstration that's been done for a long, long time. It's called the Monkey Hunter demo. And I'm sorry, I didn't invent the name. Some people are really against the name because they don't like the idea that you're shooting at monkeys. Sorry, I didn't invent that name. But basically the question that was posed said something like this. If there were a monkey in a tree, here's the tree, the blue and red thing is the monkey. If there were a monkey in the tree, and the monkey was hanging from a branch, and then there were a hunter, this is the hunter, over here, and the hunter was aimed at the monkey, and at the exact moment that the gun was fired, the monkey let go of the branch. Would the monkey always be killed? Now, it seems like, well, if the gun's sighted in and all that sort of stuff, well, if you're aiming at the monkey, you shoot, and the monkey's dead, you know? Because, we'll face it, basically, I mean, a bullet goes so fast that the second the monkey lets go of the branch, the bullet's already there. And people say, yeah, I got that. But, what if this is a low-powered gun? I don't know what sort of gun would be low-powered and still be able to kill a monkey, but anyway, a low-powered gun, and so basically the monkey falls a little bit as the bullet's traveling, so it's slow speed. Would it still kill the monkey? Kill, I mean, would the projectile hit the monkey? And then it was like, well, I don't know. So what we're going to test this monkey hunter theory here, and we'll see what happens, and then we can talk about it a little bit more. So first thing I do is I sight in the monkey, and I've done this ahead of time, but I'm just checking. Looks like it's still sighted in, so I can take my scope off the quote gun here. So I take the scope off, get one of these projectiles. Oh, by the way, I didn't explain this. So the way that the gun and the monkey are synchronized so that they both, you know that the second you fire, the monkey lets go. The way we do that is there's a battery in this device here, and when the gun finally releases the projectile, it hits this switch. And this switch turns off the magnet, because this is an electromagnet right now that's holding it up there. And it turns off the magnet, so the moment that thing fires, the monkey starts dropping. You know that they're timed the same, just so you understand how that's working. Alright, so we pull this sucker back here. About that much power should do it, and whoa!
Awesome.
Got the monkey. Now I don't know if you could even, it's hard to see. You might have to, replay the tape or whatever to see that, but the projectile got fired. And where did it actually hit the monkey? Like, where was the monkey in comparison? Monkey started here. Where was the monkey when he got hit?
It was like halfway down.
He's about halfway down. So, the monkey was here, but when we started, the projectile, if the projectile had traveled in a perfectly straight path, it would have hit the monkey right here. That's if the projectile was being fired at a high speed. The projectile was fired at a low speed. So what did the projectile do? It starts arcing. Parabolic motion, projectile motion. The trajectory was parabolic. So it ends up that, boom, they hit right about here, halfway. How can you explain that?
They're both being accelerated by gravity at the same rate.
So, I'll repeat what he said in case you can't hear it on the video. Both were being accelerated by gravity at the same rate, he said. So, alright. I like that explanation. It seems to work pretty well. So let's do it one more time. And this time, I'll try to fire it even a little bit slower. I'm going to try to make it so it hits the monkey way down here. That just allows you to see it a little bit better, I think. But first, I got to scope it in. So, it's still lined up. Nothing moved. Oh, do you hang that back up? I just touched the trigger.
Reverse it.
Yeah, right, there's a metal pin right in there. Working? Okay. So, that's full power. Power, I'd say here. Alright, let's try it again. Fire in the hole. Ooh, good, good. did just about what I wanted it to do. So, projectile was fired, hit the monkey all the way down here, boom, right about there. So you can definitely say when you see that both objects were being affected by gravity, and since both objects were affected by gravity for the same amount of time, they both lose or get pulled down towards the earth the same amount. How does this relate to a previous demo we did? I want you to think back. The one...
Oh, the one with the thing over there.
Yeah, I was over on the other side of the room, and I took one projectile and I just dropped it straight down. And the other projectile, I fired it out like this. And they were also triggered so that they would both happen at the same time. And what if we played it in slow motion, what did it look like? Well, if this one had fallen down to here, and this one had gone out and fallen down to the same height. This is the same demonstration, but why it confuses people, most people don't see it right away, is because this is not a case A anymore. This is a case B. See, case A, it's firing horizontally. Case B, this is fired upward. So most people think, well, that can't be true anymore. But the way I want you to think of it is this. If you draw a straight line like this, see, these line up, straight line-wise. So if you treat this as the straight line, then the amount it fell, that's the same as thinking of horizontal in the amount it fell. Do you get the relationship there? It's just that this situation's kind of tipped at an angle, whatever that angle is. So for today, the monkey hunter,